Okay, so good afternoon, everybody. Thanks to Mirek for invitation and for introduction of myself. With respect to the previous presentation, I will be more theoretical, like more high level, because my speech is more about giving you idea what the 5G will be, how it will be. The outline is split into three parts. In the first part, I will speak about kind of motivation. Why do we need 5G? What are the services and scenarios which are of interest for 5G, and what are consequent requirements on 5G mobile networks? Then I will focus on some potential key enablers of 5G from the technology point of view, and in the last part I will outline time schedule for standardization and for commercialization of 5G products. I will start with this picture which was prepared by 5G DPP. It's a private-public partnership which was established by the European Union in order to push 5G mobile network research and development. And this picture shows what we can expect in the future in 5 to 10 years. So every year the amount of traffic carried over wireless network increases roughly twice. So in 10 years it's 1,000 times more traffic which needs to be carried from users to network and vice versa. At the same time, amount of people using internet services is increasing dramatically. In the last year there was 1.75 billion of devices exploiting mobile networks. In 2020 or 2025 it might be much more, it could be around 7 billion. These numbers are just estimates, and if you check estimations or predictions of different companies, these numbers are also different. But it will be a huge amount of people connected to the network. Besides people, there will be a lot of devices. You know, today everything is going to be smart. Smart buildings, smart cars, intelligent transportation. Everything is intelligent, maybe but people. In 2020 there should be 7 trillion or at least a couple of trillions devices which could be potentially connected to the mobile networks. To handle such a high number of devices, such a high number of users, requiring a lot of capacity, we cannot simply improve network by adding new base stations, extending spectrum, because it would be extremely energy demanding. So with the evolution towards 5G networks, we also need to focus on energy saving. And the prediction says that we should save roughly 90% of energy consumption with respect to network as it is today. Another important aspect is latency. If we want to enable new services, real-time services, we need to minimize latency to make the people feel that they control everything like real-time with zero latency. Now let's focus on scenarios and use cases. This picture is taken over from one of the first projects funded by European Union, Episode Mantis project, and this project is supposed to define a framework for 5G networks in Europe. And the guys defined 5 major scenarios. The first one is amazingly fast. This one represents high bit rates. For this kind of scenario, we have plenty of use cases where we need high data rate, high throughputs. An example could be augmented reality or virtual office. I don't know if you have noted, in Barcelona at Mobile World Congress there was a demo of ExCom, and they create a virtual digger. The digger was in Stockholm, and people can control it from Barcelona remotely. For this, you need very low latency but extremely high throughput, because you need to transfer images and video stream from one place to another one. So this is typical use case for amazingly fast scenario. If we have high throughput for one user, It's something we can do even with by simple extension of spectrum. But what if we have a scenario which is very up to date, because you know in 2 weeks we will have the World Ice Hockey Championships, and if you have plenty of people in one small area at the stadium, and all of them are willing to share pictures or videos at the same time, you need to provide them with a great service, even if they are in a crowd. So it's the second scenario. If we speak about mobile network, we should assume mobility as well. It's represented by best experience follows scenario. In this scenario, we assume that the users are mobile. It doesn't matter whether they are walking, running, cycling, or riding a car. But the service should be of high quality for all of them. The fourth scenario is denoted as super real-time and reliable connection, which is very important, because if you offer high quality of service, you need to be sure that the service is reliable, especially for emergency situations and for, say, communication of machines, where any malfunction might be very, very dangerous. And the last scenario is related to the number of communicating devices and communicating things, like sensors or actuators and other devices. If we want to provide such kind of services, we need to think about what should be technical parameters of future mobile networks. Everything what I will be speaking about later today is my vision, which is based on inputs from researchers from all around the world, but currently nobody knows what exactly will be 5G. We will know more in 2017, when ITU is supposed to provide requirements on 5G mobile networks. So, we need to increase, we can assume that the amount of data will be increased, we will have much more devices, we need to provide users with high bit rates, with minimum latency, and we need to prolong battery lifetime. Now let's see what is currently expected from 5G networks with respect to 4G networks. In this figure, you can see 7 axes representing different KPIs, key performance indicators. The first one is peak data rate, which is maximum data rate which is achievable by the network. Self-edge data rate, it's a data rate which user can achieve if he or she is in between two cells. Spectral efficiency, mobility, it means up to which speed users should be served. Energy and cost efficiency, number of connections which are run simultaneously, and latency. For 4G, requirements were roughly like this. It means peak data rate was 1 gigabit, for cell edge data rate was order of megabits per second, so you can see quite significant difference between throughput for users in the cell center and at the cell edge. Spectral efficiency, couple of bits per second per hertz, it's assumed without multi-antenna technologies. Mobility supported up to 350 kilometers per hour. Energy and cost efficiency is equal to 1, it's just a relative number. Hundreds of thousands simultaneous connections per square kilometer, and latency up to 10 milliseconds. For 5G, the situation now is expected to be like this. Of course, this can change, but it's the vision which is generally shared by major companies and major researchers. You can see that the number of simultaneous connections should be roughly 10 times higher, as well as energy and cost efficiency, spectral efficiency as well, roughly 10 times higher compared to 4G. Latency should be reduced somewhere around 1 millisecond, which means that everything what you will do at the mobile phone will be immediately reflected at the other side of communication chain. That's why 5G is also sometimes denoted as tactile internet. Very interesting is this change, mobility. Because currently, most of the researchers assume that the 5G should support velocity up to 500 kilometers per hour. Yesterday, I was thinking, what's the difference between 350? I checked how fast are trains in Europe, in Japan, and most of them is up to 350 kilometers. And if some of them are faster, they are faster than 500 kilometers. So with extension from 300 to 500 kilometers, there are basically no cars, no trains. So I'm not very sure about this 500 kilometers per hour because these extensions might be quite demanding, but bringing no big advantage. You cannot serve users in aircraft directly, of course. So this might be different in the future. You can see interesting increase from 1 gigabit to 10 to 50 gigabit per second as a peak data rate. This sounds like amazing increase, but in fact, if you realize that first 4G standard, which was released in 2011, provide 3 gigabits per second, and a few months ago, Samsung demonstrated, I guess it was Ericsson, sorry, demonstrated 5 gigabit per second throughput in with real hardware. Then increase to 10 or 50 is not so critical. Much more interesting and much more challenging is to increase salvage data rate from a couple of megabits to gigabit. This idea basically says that the quality of service over the network should be flat, or more flat than in 4G networks. So, now let's move on and let's focus on enabling technologies. I group all technologies into three, let's say, larger groups. This is just my vision. Again, it's not something that is somewhere defined. So the first group is related to spectrum. In 5G, we assume that the spectrum will be much larger. We will use millimeter waves, unlicensed bands, and so on. And also spectrum will be shared. Spectrum sharing among operators is something that is going on in research for a long time, but it's not applied in the real network. By the way, the European Commission announced some kind of prize where you can win 500,000 euros, if I'm not wrong, if you come up with the best idea how to share spectrum among operators. The only problem is that you have to prove your idea by a kind of demo. The second area is related to communication itself. It's more about physical layer. So it's assumed that more antennas will be used. Currently in ongoing version of 3GPP they speak about 64 antennas. Also active antennas, which are known as beamforming, are one of the key parts. The idea is to focus beam of signal only to the user, which is targeted by the signal to minimize interference to other users. Higher order of modulations is something that is partly considered right now in, let's say, 4G+. Possibly new coding to be developed. Very interesting discussions are in area of waveform and multiple access or full duplex. I will speak about it a little bit more later. And in the third part, it's about architecture and deployment of devices in the network. So definitely for 5G, continuous research will focus on automatic optimization of network. It's called self-organizing networks. It means if you deploy a new entity to the network or if you change situation in the network, everything will adapt automatically without the need of human perception. In 4G, a very well-known topic was heterogeneous networks. Currently we speak about ultra-dense heterogeneous networks. It means different technologies with ultra-dense deployment of base stations in the network. Interesting idea is also device-to-device communication, where the user in vicinity of another user can communicate directly without the need of transmit signal to the base station. Software-defined networking and network function virtualization are also aspects which are very likely to be part of 5G. And quite specific is integration of cloud to mobile networks. Currently, everything is converging together, and in the last part of the presentation, I will show you some ideas how cloud can be merged with mobile communications. So now I picked some interesting or promising technologies, and I will introduce those a little bit more. So I'll start with spectrum. Currently, you can see in this figure in 2015 we have in Europe a couple of hundred megahertz band available in licensed spectrum. It's quite a lot of spectrum, but it's not enough to provide 50 gigabits per second. Very interesting. Spectrum seems to be in millimeter waves. It means in frequency bands in tens of gigahertz, between 10 gigahertz to, let's say, 100 gigahertz. In the project Metis, the guys did some research and identified potential bands of interest, and you can see that there is tens of gigahertz, which might be available. Of course, most of these green parts are currently occupied by other technologies, but potentially these technologies or spectrum assignment can be changed in the near future. So there will be a lot of spectrum available, and a lot of research work was done to prove that communication in such bands is feasible. If you are interested, I remember work of Professor Tedra Papor from New York Polytechnic. They did real field trials to prove that 30 gigahertz band is feasible for mobile communications. But to enable communication in millimeter waves, there is a lot of, let's say, politic fights because of spectrum. Much easier is to consider unlicensed bands. In Europe, we have roughly 500 megahertz available at 5 gigahertz and at 2.4 gigahertz, where usually Wi-Fi is deployed. In LTE advanced or before, unlicensed spectrum was out of the table. It was not an option. Until even release 12, which was completed 1 month ago, everything is only about licensed spectrum. But since release 13, there is new technology which is called license assigned aggregation, and it assumes exploitation of unlicensed band. The idea is slightly related to carrier aggregation, which is quite old. It was introduced in 4G, and it enables the user to communicate through one band and append additional band if it is required. For example, if you need higher throughput. If you replace this secondary band, which was originally licensed, with unlicensed, you cannot guarantee quality of service. But if you want to download a movie or a lot of data, you don't need low latency, you need high throughput. And this is exactly objective of communication in unlicensed bands. One assumption is that user will be always connected through licensed band, and unlicensed one will be just for boosting capacity or throughput. New carrier type. It's also related to spectrum, but it was introduced like 5 years ago, maybe more. But then it was removed from standard, it was discussed heavily. And maybe you heard about phantom cells or link carrier. All of them are roughly the same. The motivation for new carrier type is problem with overhead. In LTE, the overhead, signaling overhead, can consume between 15 to 50% of resources at the radio, which is a huge amount. And if a user is exposed to one cell, he can still receive signaling from the serving base station, but resources which are originally occupied by signaling might be occupied by data in transmission from another base station. The problem is backward compatibility with previous standards. That's the reason why it was removed from the list of study items in 3GPP currently. and I had discussion with a guy from ExCom, and he told me that they plan to push it again once millimeter waves will be ready. Now let's see on communication. In 4G, time division duplex and frequency division duplex were two options, only options which were available for communication. Currently, in 3GPP there is a study item on combined duplex where in the FDD, as shown in this picture, usually uplink is not heavily loaded because most of the traffic is in downlink. So instead of having separated spectrum for uplink and downlink, you keep separated the spectrum for downlink, but the uplink is replaced with TDD, time division duplex, where you can switch uplink and downlink according to your needs. One step beyond is idea of full duplex. It means your mobile phone will be transmitting and receiving data at the same time at the same frequency. It sounds quite simple, but the problem is that if you transmit from your mobile phone, signal which is transmitted is of much higher level than signal which is received. This could be suppressed by cancellation, because if you know signal which is transmitted, you can just subtract it from signal which is received. But the problem is that in every environment there are different objects around you, and the reflection of transmitted signal, which is also received by the receiver, can strongly influence decoding of the signal. So it's a big challenge how to avoid impact of this reflection from environment around mobile phones. Once this will be solved, full duplex is a very good solution which simply nearly twice increase throughput. Another very interesting discussion is about multiple access. I heard opinion of three companies, Ericsson, Alcatel and Nokia. They have different opinions on what kind of multiple access will be in 5G. Some of them says that OFDMA, which is used in 4G, is fine. It might need some tuning, maybe waveform might be changed a little bit, but we can keep it. But others says that OFDMA is not good enough for future networks. An alternative is non-orthogonal multiple access. The idea here is to differentiate signal by transmitting power. I'll try to explain with this figure. Let's assume that you have base station, one user, and second user. You transmit at the same time at the same frequencies for both users, for each of them with different power. So, for this user which is closer, you transmit only with some smaller power. For a user which is more far, you increase power. For the second user, the transmission is very simple because signal level of this blue user is like noise or interference. So user 2 can easily decode his own signal. But the problem is for this user, because for this user, his signal is hidden and it's like noise with respect to the signal of user 2. The idea here is to first decode signal for user 2 and subtract this signal from this value, from combined signal for both users. Of course, this can be further combined with frequency division or time division, but the power is new dimension how to separate signal. It's a little bit step back, because you may remember that in 3G there was CDMA, where you transmit over one band the signal for all users, but differentiate by different codes. Now let's see device-to-device communication. Up to release 11, all the communication was always routed through the base station, the core network and MAC, even if we would call together in one room. Always the signal would be routed to base station. Now in release 12, there was introduced device-to-device communication. So if the users are close to each other, they can exchange data directly. In this release, it's only for public safety scenarios. So for case of emergency, when the network is down, for example, such scenarios. In the future, it's very likely that this kind of communication will be enabled also for public usage. But of course, operators are not very happy about this because they are losing part of control about network. It's very hard to control interference. I will speak about it on the next slide. But there are clear benefits of device-to-device communication, especially in terms of saving radio resources, because you have just one hop in communication. In conventional communication, you need to transmit data in uplink and then in downlink. Here you have just one link. And also, packet delay might be much lower because you don't need to decode signal or to gain. What are key challenges? First of all, the most important challenge is to choose which mode should be used. Whether I should communicate directly with another user or through base station. If you communicate directly, you can reuse resources of uplink or downlink, and you can dedicate resources for device-to-device communication in frequency or in time with respect to the other users communicating conventionally through the base station. If you share resources for device-to-device communication with conventional communication, then you have problem with interference, because you can see all these red arrows represents interference which is introduced by device-to-device communication, because now you have many different pairs communicating directly with each other, and each pair introduces interference to other pairs as well as to conventional users. So the challenge is how to mitigate this interference. And everything becomes much more complicated if you consider mobility. If the system is dynamic and the situation changes all the time. Another problem is machine-type communication, when you need to enable millions or billions of sensors or devices communicating through mobile network. This kind of communication was introduced in 2013 in standards, but still it needs to mature a lot, because the problem is you cannot assume that sensors will use some advanced antenna techniques. You cannot deploy MIMO to simple sensor which needs to survive with a small battery for years. So you need to enable very simple communication of such devices. The problem might be also the amount of data transmitted by sensors or by devices, because usually it's a couple of bits. And if you want to transmit a couple of bits and you add overhead of upper layers, you know that you are losing a lot because of this overhead. So all these challenges are very interesting. Also, access to the channel. If you have millions of devices trying to access the same channel, there will be a lot of collisions. So, big challenge is to find an algorithm which will be efficient in terms of collisions. Briefly, I will also speak about heterogeneous networks. Heterogeneity can be understood in two different ways. The first one is a combination of different technologies. Not only cellular networks, but also Wi-Fi, which is currently investigated, or WiMAX, or other technologies which will arise in the future. Another dimension is cellular radios, because maybe I will show on the next slide. You have different radiuses of cells, basically except femtocells, which are a little bit specific because you have a different backbone to the network. But pico, micro, macro cells are roughly the same devices, it's the same equipment with different computing power. But bottom three parts are usually coupled and denoted as small cells. The idea is partly because of smaller radius, but mainly with the scenario which is introduced if we deploy small cells into the coverage of macro cell. In this scenario, we have overlaying networks where we have not only interference between base stations, but at the same level like it was in the past, but also interference between small cells to users which are served by macro cells. It's called cross-tier interference. So the scenario of interference is much more complicated and needs a lot of attention. But this is not a very new. This problem started to be solved 5 years ago. There are still some partial problems to be solved, but it's not the newest way. Relay stations. Also, relay stations were introduced in standard a couple of years ago. I will not go into details because I guess most of you know. I would like to mention mobile relays. Mobile relays are kind of base stations mounted on vehicles, and this relay communicates with the base station and serves users inside the bus, inside the train. It was discussed at 3GPP, but I think the appropriate time for this kind of relays will come up with intelligent transportation systems. I will mention later when we can assume this kind of communication will be considered in standard. I have mentioned that there is an idea of exploitation of unlicensed band. Typically, Wi-Fi is a technology which is mostly used in this kind of bands. And up to release 11, cooperation between Wi-Fi and cellular networks was very, very big. There was interworking gateway, which was kind of translator between Wi-Fi protocol and 3GPP networks, but it was impossible to control both kinds of networks and exploit their cooperation to improve performance. The idea of 5G is to integrate not only Wi-Fi but also other technologies, but Wi-Fi is currently the most interesting one, into one let's say block, where the user equipment will be able to measure signal quality of all available base stations, doesn't matter what technology it will be, and moreover report it to the base station, which can decide whether the user should be served through cellular network or through Wi-Fi. I found some interesting figures drawn by Nokia. They were comparing efficiency of LTE and Wi-Fi, and of course LTE is much more efficient, but the even higher difference is in case of interference. If there is interference, Wi-Fi is failing. It's not able to do interference efficiently. So that's the reason why cooperation of both technologies is very important. And now let's focus on architecture. This is architecture of LTE. It's not new for you, I guess. We have user equipment, base station, small cell base station, common base station, and core network, which is composed of mobility management entity, which is for signaling, serving gateway for users' data, and packet gateway. 5G architecture must be compatible with 4G, but with respect to 4G, it must be flexible and must be able to control and adapt to different services and different applications, different requirements of users or applications. It must reduce energy consumption, must reduce latency, and it must enable new services. There are plenty of solutions. I will choose some of them, and on the next slides I will briefly explain. The first idea introduced by China Mobile Research in 2011 is known as centralized RAM. It's again step back to previous generations, because with new generations, network control was more distributed and pushed toward the edge of the network. Because in 2G there was base station controller which was controlling a couple of base stations. In 4G intelligence was at the edge of the network. It means in the base stations. This centralized RAN is simply the idea to concentrate the control logic in one place, because in this way you can easily optimize usage of resources, and you don't have to spend a lot of money for deploying quite costly equipment at every place, especially in case if you have a base station which will not be used for 100% of time. If we replace this specific hardware which is concentrated in one place with a cloud solution, we speak about cloud radio network, cloud RAN. Very interesting approach was introduced by a PCM project I joined, and it's called RAN as a service. Here the idea is to dynamically decide whether the control functionalities will be taken closer to the edge of the network or more in a centralized way. So you can dynamically change placement of central logic from base station to cloud. Another concept which is very promising for future networks is content caching. Currently, if you want to download any content, usually the content is stored somewhere in the internet. So it's far from you. You need to download it from far servers, from far disks, and you load backhaul network. If we store content at the base station, we can dramatically reduce load of the backhaul and latency. But of course, it assumes that there will be storage at every base station or nearly every base station. So it's not only, it has also some cons. And last technical part is about cloud computing in 5G. Most of you, I guess, have a smartphone, and smartphones are no longer used as common phones like 10 years ago. So you use it more like computers. You play games, you organize your time, you have some applications which you can exploit in your mobile phone. The problem is that even if mobile phones are quite powerful, you can have problem with applications which are demanding in terms of computation. The problem is not in CPU, because CPUs are quite good. The problem is with battery. If you run an application which needs a lot of computation, your battery is going down, and you drain your battery in a couple of minutes or hours. The idea which is known as mobile cloud computing is to offload computation from mobile phone to a centralized cloud. But here the problem is delay. If you want to offload application, you need to transfer it somewhere else. And if this else is far from you, it can take a lot of time, so you can forget about the real-time services. If you want to enable real-time services, you need to perform computation closer to you, closer to mobile phone. And mobile networks, obviously, it's base station, which is the closest place for you. So we have introduced a concept which is called small cell cloud, and it merges mobile communication with cloud computing, put it into one pod, and enable optimization of communication and computation together in order to optimize battery consumption and delay. Of course, this concept requires some changes in architecture. We need to introduce entity, which is in charge of network control in terms of computation. This is now called small cell cloud manager, so this block is in charge of computation. And if you need to compute at the base station, you need to equip base station with some additional CPU, some processor, which can be used by users. Of course, this computing power that can be virtualized over library base stations and provided to the users. And typical example of application which can benefit from this is augmented reality, which shows you information about your neighborhood. If you want to discover what you can see through your mobile phone, there is a lot of computation which needs to be done in order to identify what you can see. And we did some demonstration and compare computation at the mobile phone with one at enhanced base stations with small cell cloud. And you can see that the energy as well as time of discovery of places, which you can see for the computation at mobile phones, is increasing nearly exponentially with the distance within which you are looking for places. But if you offload computation, energy as well as discovery time are getting separated, and if you are searching in an area of 500 meters far from you, you can reduce energy and time more than 10 times. So, in the last part, I will focus on standardization and schedule for 5G. Just a very brief introduction. ITU and 3GPP are two major organizations which are related to mobile communications. ITU defines a framework for mobile communications, and 3GPP defines standards itself. Currently, the newest release is release 12, 3GPP release 12. It was frozen in March 2015, which is less than 1 month. And in this standard, there was integrated Wi-Fi, machine-to-machine communication, and device-to-device communication for safety services. The next release, which is in progress, is release 13, and this one is scheduled by end of this year. I doubt it will be delivered by end of this year. I don't even think it will be delivered in March 2016. I guess it will be rather middle of next year. But those two standards are sometimes denoted as LTEB. It's rather a commercial label. It's still LTE, but sometimes you can see that it's LTE. And those two standards together should increase capacity roughly 30 times with respect to previous versions. If you remember, I mentioned that the capacity should be increased roughly 1,000 times. So 30 is roughly in half. Because 30 times 30 is 900, so we are nearly in half after release 13. What next? As could be expected after release 13, there will be release 14. The question is whether it will be 5G or not. There is one interesting topic for this release. It's vehicular communication, V2X, vehicle to infrastructure or vehicle to vehicle, and also communication of IoT devices. There is no date when this release should be frozen, but expectations are end of 2017, maybe 2018. And after this standard, there will be most likely release 15. Which is again, this one didn't even start it, and we don't know when it will be completed, but I would expect end of 2019. Now let's put together requirements and the schedule of ITU and 3GPP. I have mentioned that in 2017, in February, ITU should define requirements on 5G mobile networks. After this, there will be a period for submission of ideas of candidates technologies. So 3GPP will submit standard or some documents which will describe their vision of 5G from the technology point of view. So they will describe what exactly 5G will be in 3GPP. The deadline here is mid of 2019. After this, there will be evaluation period, and after the evaluation period, there will be final submission of standards in 2020. A couple of weeks or a month ago, 3GPP announced plan to submit final version, which will be frozen in December 2019, to ITU. So in 2019-20, there will be first, most likely, there will be, of course, it's not 100% sure, but it's very likely, we will have first 5G label standard. Of course, 5G is just a label, commercial label. I saw the presentation of Dino Flore from 3GPP, and it was about road to 5G, 3GPP road to 5G. And in the presentation, he said that it's the last time when they are using term 5G in 3GPP. For them, it's not so important, it's not more commercial. So we can expect first products in 2020. with respect to those dates, it's very likely that release 15 will be the first one, which will be official 5G.
Excuse me, so I have a question, because it's very interesting, this standard, the release 14, because we saw we have one idea focused on the broadcast for public learning. Do you know how it should work, and what idea is behind this notice broadcast for public learning?
Good question, honestly. I didn't pay attention to this one. I'm more focused on V2X, but I can check for you. Because currently CTU or university is 3GPP member, so I have access to the documents. I can check. And
so it's possible to...
there is a study item on this topic.
In location area or individual cells of the mobile structure with some text message or...
I guess it will be in case of emergency. Mobile network will be used to spread emergency information. This is core idea.
So it's very interesting. It's very important for us because we are going to have a project in this area, and if it is in
so you are basically working on 5G
standardization. No, if it is in program standardization. So
no, this release 14 is it's in progress, but the work is continuous. Now release 12 was finished. Work on the release 13 is ongoing, and even if this release 14 started in March 2013, in the first stage there is usually analysis and collection of ideas which could be included in the release 14, and the real work on the definition of everything will come up later. Okay? So, nearly last slide. Schedule towards 5G. Here you can see how long does it take from launching one technology to launching another one. And it's roughly 9 to 10 years. And as the 4G was launched in 2010, we can assume that in 2010 work on 5G officially started. Even if officially ITU started their work by starting 5D working party in 2012, and in Europe work on 5G was officially started by several projects launched in 2012 or 13. But we can assume that even having in mind the previous slide, 5G should be ready in 2020. But it's very interesting that many companies are planning to launch 5G even before 5G will be officially defined by standard. Telecom, SK Telecom, it's Korean telecom. ExCom would like to exploit Olympic Games in Korea to demonstrate their 5G solution, which will not be standardized. It will be in line with standards, but it will not be labeled as 5G. But it should fulfill requirements of 5G. In the same year, Huawei would like to demonstrate their solution in FIFA World Cup in Russia. So in 2018, most likely we will see first 5G solutions which are in line with the requirements of ITU. So that's all. To summarize, 5G is motivated by new services, scenarios and applications, and mainly by convergence of all technologies, cloud, IoT, smart everything together, and in touch with mobile communication. First certified commercial products of 5G should be ready in 2020, but we can assume first hardware and first networks demonstrated in 2018. And currently we cannot say what 5G will be. We have some overview, we have some ideas, but there is still a lot of work to be done. And if somebody comes up with a new excellent idea, a new service, all that I've presented can be a little bit changed or tuned or aligned. So that's all. Thank you for your attention. you have any questions?
Questions? Comments?
Can I have a question?
Yeah, of course.
What do you think about the real situation if in 2020 the 5G will be something like standardized? Is it real? Because from my experience, from your experience, you know that all the releases was delayed. Yeah, so it's only idea, or what do you think? Because I think that it's very
Very close.
yeah. Release 16 will be released in 2020. I think that.
I think it's nearly for sure.
Mhm.
It will be ready. Because 3GPP set this date, December 2019, as their
It's on the
hard
yeah.
deadline, and they will tune all the intermediate deadlines with respect to this one. And what is important, the work is ongoing continuously. So they work on it continuously, and they will submit to ITU the version which will be ready. And it's very likely that even the versions ready in 2018 will be in line with ITU requirements. But what is important, frankly, is just like it's marketing label.
Yeah.
Just a milestone.
Okay.
Okay. Other questions? No questions, no comments? Okay, so now we are very close to finish the end of our seminar, and in program we have a